matrix, you make this, we're going to start designating things. This inner loop we're going to say is current for this thing is I1. And the current around this guy we're going to say is I2. Okay? Starting off with, right? So we're going to have to come up with an equation kind of matching what we're seeing here, right? So for the first one, we can say it's 6 is the amount of ohms times I1 plus, and we have 4, it's being the ohms for R2, 4 times, in this case it would be I1, but you also have to subtract what you're going to be having in this circuit. So it's going to be minus I2. And this whole thing is going to be equal to 12 volts, right? Now we'll do the guy in the center. For this one, we just keep writing things across as we see them. So it's going to be 4 times I2, and now you got to subtract the current that's going in that ring, so it's minus I1, and now we're going to say plus 2, right? Going, in this case, it'd just be I2, that's going to be equal to 0. All right, now, all you got to do now is distribute what you're seeing. So let's give that a try. 6I1 plus 4I1 minus 4I2 equals 12. And this guy would be 4I2 minus 4I1 plus 2I2 equals 0. And now we're going to combine like terms. So I just keep putting lines here, so I'm going to do it for each step. Okay, so let's give this a try. So I1 plus I1 is 10I1. 10I1 minus 4I2 equals 12. And let's try this guy. So we're going to combine like terms. I1s, we only have a minus 4I1, right? And we go 4 plus 2, we have 6 plus 6I2. That's going to be equal to 0, right? Now, when you're doing the matrix thing on your calculator, you're going to drop the i's, you need those for what we're going to do. So I'm just going to write it again, and I know this is kind of, for some people, why is he doing this? For some people who haven't had it yet, right? Or haven't had it a long time. 10 minus 4, 12 are the numbers we're going to use. And for this guy, it's going to be minus 4, 6, 0. So now I'm going to bring up my calculator to do this next part, okay? So once again, we're going to go here. All right, so I'm going to turn on my calculator. I'm going to go to second function, x to minus 1, which is matrix, okay? Now I have a 2 by 3 combination. You might not have anything, but let's say I'm just going to go down to one that's blank, so you can see how to do this. I hit enter. I'm going to go down to 3, scroll over 1, 2, I'm going to hit edit. So I'm going to come down here. I'm going to show you how to do this. We'll hit this. I'm going to say it's a 2 rows by 3 columns. Hit enter. And they line up my things. Now I just got to put the numbers in. 10, enter, minus 4, enter, 12, enter, minus 4, enter, 6, enter, 0. Enter, right? Once you get this, you're going to back out, second function mode, we're going to escape this thing, and then go back into it as we're going to do the math. I go math, I'm going to go down to RF, right? I'm going to hit enter, and now I got to find which matrix I want to do. I go second function, I go back to the matrix. This is the one I just did C. I'm going to hit enter, enter. It gives me these numbers, okay? These numbers have a lot of meaning. So I1 is 1.64. I2 is 1.09, right? So I'm going to write these down. I1 is 1.64. So I1 equals 1.64 amps. I2 equals 1.09. So if I come back in here, and let's say I want to now do somewhat of a array of blocks, looks like this. There's not that many guys here. It's only 3, right? So I can say R1, R2, R3. So this is R, A, B. This would be 6. This is 4. This is 2. So for this guy, I'm going to put in simply straight 1.64. Okay? And if I multiply across, I'm not going to go back to the calculator. I'm going to just do it right here in front of me. So, right, 1.64 times 6, you get the number 9.84. Okay? 9.84. 4 is a little confusing. We'll come back to him, right? But first, let's do this guy down here. He's all by himself, so I can put 109. 1.09, so 2 times 1.09. 2 times 1.09 is 2.18. 2.18 volts, okay? 2.18 volts, okay? Now, we're going to have to ask ourselves, we know that we have to get 2.18 volts, right? We know that's what's going to answer because the volts are the same parallel thing. But there's another operation we can do to get this answer, okay? So pay close attention because I'm going to show it to you right now. We take the outer root. It's going to be I1 minus I2. So it's going to be 1.64 minus 1.09. It's going to give me the current that's going through that one resistor, right? So I go 1.64 minus 1.09. You get the number 0.55, okay? And where's my little cursor? 0.55 times 4. You're going to get almost the same number. Of course, we're doing rounding and there's things that are going on. This is going to be 2.20. Okay? So this is kind of an interesting way to do this. Obviously, you can see right here that you can use a matrix to kind of solve these things. And the other video, I show how to go into a more, how would you say, bigger, more complex circuit to do it. So I'm actually going to do a RAV table real quick to show you that the numbers do match out. Okay? So I'm going to scroll down and do it right here, right? First of all, because it's the circuit that we've seen before, it's really kind of easy combination one. I'm going to put down R1, R2, R3, R2, 3, our total, right? He's on the outer ring, he's on the outer ring, okay? So I'm going to make sure I put my numbers in correctly. If I don't, it's going to be a mess. 6, 4, and 2, right? So this is 6, this is 4, 2, right? And we're going to make this an RAB, okay? So if we get the comparable resistor, 1 divided by 4 plus 1 divided by 2 equals 0.75 would be my comparable resistor for this guy. 5. If I count my outer ring, it's 6.75. I have 12 here, right? 12 divided by 6.75, I get the number 1.77, 1.78, okay? So that's interesting. What did I do wrong? 4, 4, 6, 4, 2, 6, 4, 2. That's not right. This is 1.33. I did not push the button. Let's go down here. So if you take 1 divided by 4 plus 1 divided by 2, and then you take the reciprocal of this, you'll get the number 1.33. 6 plus 1.33 is 7.33. 12 divided by 7.33, you get the number 1.64, right? 1.64, which is going to go to this loop. It's going to go up to this guy, 1.64. Now let's look, let's scoot up. Yeah, that matches. 1.64, 1.64. So this must be 9.84, right? Just doing the same thing. This guy, if you take 1.33 times 1.64, you get the number 2.18. Just what we thought was going to happen, 2.18, which matches this guy right here. We slide him up, 2.18. 2.18. And if you did that, you're going to get the number what? 2.18 divided by 4, you get the answer 0.545. 0.545. And then 2.18 divided by 2, you get the answer of 1.09. So you can see that both of them work equally well for solving a more complex circuit. It may be better to use the matrix table. We'll show you that later on. Okay, excellent.